creating chat applications using the LangChain Python library and OpenAI's large language models. Let's start from the beginning. LLMs are models that can process human language and generate human-like responses. The large part in the name refers to the enormous amount of data these models have been trained on, and consequently, their impressive number of parameters. But how large is large? Well, as the training data grows and models become more knowledgeable, the meaning of the word large adapts. OpenAI's GPT-2 model, released in 2019, is reported to have an astonishing 1.5 billion parameters trained on 40 gigabytes of text. We can't argue that these are impressively large numbers, but now compare them to the GPT-3 model released a year later, a model with a whopping 175 billion parameters, trained on 570 gigabytes of data, roughly the equivalent of 400 billion tokens. And imagine that even those are rookie numbers compared to the size and training of the GPT-4 model. So the word large is not anchored to specific numbers, but is an umbrella term for models of this scale. Well, researchers in the field can always take inspiration from the creative names astronomers give to their telescopes, such as large models, very large models, and extremely large models. But given the rate at which new and more capable models are released, I think we'd quickly run out of adjectives. All right. A subset of large language models is explicitly trained to hold a conversation. These are intuitively called chat models. An example of one is GPT, a generative pre-trained transformer. If you've ever had a conversation with ChatGPT, then you've encountered OpenAI's chat model capabilities. This course will use the GPT-4 model to create custom chatbots. For a more in-depth discussion on the inner workings of LLMs and GPTs, I highly recommend our course, Intro to LLMs with Lauren Newbold. All right, but where does LangChain enter the picture and why is it a big deal? Let's start with what it is. LangChain is a framework that allows for seamless development of applications powered by large language models. Most notably, our focus throughout the course will be to create chatbots that are stateful, context-aware, and reasoning. Being stateful refers to keeping memories of past or ongoing conversations. Context awareness refers to answering questions about information outside the model's training data. And reasoning is the power to choose among various tools and their order of execution to solve a specific task. The use cases to which we can apply such chatbots are endless, but to offer some insight, we can find ones in web browsers for summarizing the most important of today's news. We can use them to query a database through everyday language, build a multi-source fact-checker, or why not integrate a chatbot into the 365 platform to answer course-related questions? Once we solidify our knowledge of the LangChain library, we'll demonstrate how to build a 365 Q&A chatbot. Sounds cool, right? But now I want to spend a few minutes on intriguing, real-life use cases in which LangChain has played a crucial role. I'll see you shortly. Welcome back, everyone. In this lesson, we'll display real-life use cases where companies have sought LangChain solutions to deliver cutting-edge technology products to boost their staff's productivity or improve customer experience. Let's dive straight in. Consider Ally Financial, one of the U.S.'s largest bank holdings and car finance companies. Ally Financial is an all-digital bank, and as such, its employees must stay current with new technological advancements and offer innovative approaches to their clients. So, they've partnered with LangChain to develop their LLM-powered platform, Ally AI. This platform is designed to summarize call conversations between assistants and customers using an LLM. This has proven to help associates tremendously, freeing them from the mundane task of documenting conversations and allowing them to focus their time and energy on assisting customers more quickly and efficiently. Let's talk a bit about this process of summarizing the conversation between customer support and Ally's client. Providing financial assistance inevitably involves sharing proprietary information, such as a customer's name, social security number, account details, email address, and much more. Understandably, we can't simply put a conversation containing such sensitive information into ChatGPT and ask it to generate a summary. Instead, we need a bridge between the conversation and the LLM that masks this personally identifiable information before passing it to the language model. This is where LangChain comes into play, offering a module to mask such sensitive strings before making the LLM call. How cool, right? Let's now look at another use case where LangChain has proven invaluable. Adyen is a fintech platform used by giants like Microsoft, Spotify, and LinkedIn. It provides end-to-end payment services, data-driven insights, and financial control. Adyen has embraced the power of AI to ease the work and improve the efficiency of their support team. The problem they've tried to solve is to reduce response waiting time on incoming customer tickets through a smart ticket routing system. Or, even better, automatic LLM-powered responses. This would result in more satisfied customers and essentially eliminate the tedious and time-consuming task of redirecting a ticket to the relevant person, reproducing the problem, and constructing a response. Again, we can't just copy-paste a ticket into ChatGPT and expect it to help a customer or redirect them to the relevant support person. The model doesn't have this information. But with the help of LangChain, they've realized the project successfully, creating a support agent co-pilot relying on a technique called retrieval augmented generation, an important topic that we'll cover in detail later in the course. Very well, everyone. Let's consider one last use case: code completion and code suggestions. RoboCorp is a Python-based platform that enables the creation of bots to automate diverse tasks across various fields. Examples from the data extraction field include automating the scraping of prices, reviews, and other information from websites. The accountant and HR sector can also benefit by automating the monthly processing of invoices or the onboarding of new team members. Finance employees can automate the generation of financial reports, and IT specialists can create robots to test applications and websites. But of course, building an automated robot is no easy task. That's why RoboCorp has employed LangChain to build Remark, a co-pilot that can assist you with coding advice. Or why not generate an entire code snippet for you? All you need to do is explain the use case you need to solve in human language, and Remark will develop the relevant code. To make this possible, RoboCorp has provided a large model with data from many resources, including coding examples and documentation. They've successfully created a product that solves customers' problems quickly and efficiently. This has the added benefit of reducing the support team's workload as they now handle fewer support tickets and customer issues. All right, we considered 3 intriguing use cases: masking personally identifiable information, routing customer support tickets efficiently, and creating code using only plain English. But the applications don't end here. You're welcome to explore LangChain's website for inspiration, discover real-life examples, and brainstorm your own unique use cases. In our next discussion, we'll discover what makes LangChain such a powerful tool for building LLM-powered applications. See you soon! Welcome back, everyone! I hope the last lesson left you inspired and excited to build your first AI project. In our third intro lesson, we'll unravel the magic ingredient that makes LangChain a powerful tool for building LLM-powered applications. Let's get started. One of the components we need for implementing exciting AI assistants is, of course, the language model. Accessing different language models is as easy as pie with LangChain, since it integrates with many LLM providers. In this course, we'll employ LangChain's integration with the OpenAI provider to access OpenAI's chat models, more precisely, GPT-4. But as noted, OpenAI is one of many options. Once you get the hang of LangChain, you can experiment with other models, such as Anthropic's Claude or Google's Gemini. But the LLM is just one component for implementing a stateful, context-aware, and reasoning chatbot. Let's consider the first feature. As noted, a stateful chatbot refers to recalling the dialogue held this far to hold a conversation. LLMs are inherently stateless, so we require a mechanism that somehow stores the current conversation and feeds it as context to the language model. Thankfully, we don't need to search for third-party software that stores our conversations. LangChain already has those integrations built in. We just need to pick one from the list. All right, let's now discuss context awareness. That is, adapting a chatbot to answer questions on personal data, which is no easy task. First, we need a tool that loads our data. As simple as this sounds, data comes in PDFs, docx files, CSVs, among others. How do we handle all data formats on equal footing? Fortunately, there's no need to worry about this problem because LangChain offers many document loaders for our convenience. Okay, imagine now that the data we feed is quite large. Say you're making a 365 Q&A chatbot and want to load the transcript of all 365 courses. We need a place to store all this text, right? I'm sure you've guessed it. LangChain offers various integrated database choices. And what about reasoning chatbots? These chatbots utilize external tools to address diverse challenges, autonomously selecting the appropriate one and determining the sequence when multiple tools are required. How cool is that? But must we integrate our chatbot with external software to use such tools? Indeed, that would be highly inconvenient. That's why the LangChain community has worked hard to integrate many tools into the framework, such as Wikipedia, Wolfram Alpha, web search engines, Google products, and more. I find this quite exciting. As the course progresses and you become familiar with the steps to creating a chatbot, we'll also explore the different integrations LangChain offers. All right, everyone. Let me conclude this lesson by noting that I've only discussed the implementation side, but once you create a product, you need to monitor its performance and deploy it for your customers. The LangChain team is constantly working on expanding their ecosystem and providing solutions to these post-development steps. The LangSmith platform is designed to inspect, monitor, and evaluate a product. LangServe, in turn, allows you to deploy your application as an API. So, all three steps, development, observability, and deployment, are covered in this ecosystem, ensuring a smooth transition between these stages. This course will focus on the first, development, part of the LangChain Python library. All right, the goal for this course is set. Learn to build stateful, context-aware reasoning chatbots using the LangChain Python library and OpenAI's GPT-4 model. In our next and final introductory lesson, I'll outline the game plan for achieving this goal and discuss the course's recommended prerequisites so you can enjoy it without interruptions. Thank you for watching, and see you shortly. Hey everyone! In the last lesson, we provided a bird's-eye view of LangChain. We set the course goal to explore the LangChain Python library and employ OpenAI's GPT-4 model to ultimately learn how to build stateful, context-aware, and reasoning chatbots. Now let me outline the game plan for the remainder of the course. We'll start with a brief discussion on OpenAI's tokens, models, and pricing. The amount of text we pass to an LLM translates into tokens, and OpenAI's models are priced based on token usage. Therefore, researching the various models offered by this provider and the pricing of each is crucial. In the following section, we'll prepare our Anaconda environment for the course, show how to obtain an OpenAI API key, and set this key as an environment variable. After that, we'll quickly familiarize ourselves with the basics of OpenAI's API and introduce relevant terminology related to chat prompting. This will prove beneficial later when we explore LangChain's integration with OpenAI. Then, we arrive at the crux of the course, the LangChain library. We'll start by discussing the LangChain framework and outlining each of its components: model input and output, chatbot memory, document retrieval, agent tooling, and the LangChain expression language, the protocol that makes the implementation of all of these components possible. In the section that follows, we'll explore each component, starting with the topic of chat messages, chat prompt templates, and few-shot prompting. It's about asking a chatbot questions and getting the desired response. Next, we'll consider a few classes that enable the creation of a stateful chatbot, one that remembers past interactions or the ongoing dialogue. We'll then move on to discussing the output from a model. More specifically, we'll show how to convert an LLM response into various output formats, such as a string, a list, or a datetime object. This proves helpful when you need to feed the response from an LLM into a tool or application that requires a type-specific input. Once we've covered all the essentials regarding model inputs and outputs, we arrive at an intriguing topic in our journey, the LangChain expression language, which, recall, was the protocol used for implementing LLM-powered applications. This is an important topic because it builds the foundations necessary for progressing the rest of the course. Don't worry if this seems daunting at first. I assure you that the LangChain expression language is quite straightforward. As you proceed with the course, I'm confident you'll soon become a LangChain master. Next in our game plan is Retrieval Augmented Generation, or RAG for short. This is a technique whereby we cleverly feed custom data to a language model, data that it hasn't been previously trained on, so that it can generate context-specific answers. The practical example we'll use to learn about the RAG technique is feeding the transcript of lessons from the 365 library, ultimately creating a simple 365 Q&A chatbot. And finally, we arrive at the Tools and Agents section. Tools are objects that give a language model access to the outside world and allow it to, among others, browse the internet, execute code, and solve mathematical problems. An agent, in turn, is a particular object that chooses the right tools for a problem and decides their execution order. This part of LangChain gives a chatbot the ability to reason. All right, everyone, I hope you find the agenda intriguing. Before I wrap up this lesson, let me briefly mention the suggested prerequisites for this course. Since we'll be working in a Jupyter Notebook environment, you must have Anaconda and Jupyter Notebook up and running on your machine. If that's not the case, follow our Introduction to Jupyter course beforehand, which will help you get started. Next, embarking on this LangChain journey requires a beginner to intermediate knowledge of Python. I recommend exploring our courses if you're uncertain about your Python skills or need a refresher. To enjoy the course uninterrupted, knowledge of Python syntax, functions and anonymous functions, sequences, iteration, string manipulation, list comprehension, and inheritance is recommended. Finally, because this course is focused on creating chat applications with OpenAI's large language models, it's advisable that you be familiar with the terminology used in generative AI. I recommend exploring our beginner-friendly Intro to ChatGPT and Generative AI course. For a more in-depth exploration into the inner workings of these models, consider our Intro to NLP for AI and Intro to LLMs courses. This will help you better appreciate the power and purpose of large language models and the LangChain framework. I think we're now ready to take off. Buckle up and let's begin.